Name also. Good afternoon. Welcome to Zoology first year class. Last class we discussed about the Plasmodium life cycle. In this man phase we discussed. Today we are going to discuss about the mosquito phase, or also called as a RAS cycle. Here, Plasmodium life cycle in mosquito. Question will ask three ways. Write about the life cycle of Plasmodium in mosquito, or the mosquito phase, or RAS cycle. Clear? It is described by the on the oocysts and the crop is described by the RAS. That's why the name is called as a RAS cycle. This cycle name is also RAS cycle. Plasmodium life cycle in man, or also called as a RAS cycle. And in man phase, after the erythrocytic schizogony or erythrocytic cycle, the merozoites are released. Some merozoites are enter. Sometimes several schizogonies are occur. Erythrocytic schizogonies are occur. The merozoites are enter inside of the RBC and transform as a gametocytes. Formation of gametocytes we discussed. That gametocytes, where it is present, these gametocytes are present inside of the blood of man. These gametes present in blood of man. When the mosquito bites the man, here mosquito bites the man, they enter inside of the mosquito along with the other stages also. The gametocytes are the stages. These stages are present in the after the erythrocytic schizogony. The merozoites are transformed as the gametocytes. These gametocytes are present in the blood of man. When the mosquito bites the malarial patient or malarial having the man, mosquito bite, then these gametocytes are enter inside of the mosquito. Here, gametocytes along with the other larval stages also. Here, the gametocytes enter inside of the crop of the mosquito along with other stages. Other stages of erythrocytic cycle. Merozoites also there. That merozoites are enter. All the other stages are destroyed. Only the gametocytes are present inside of the crop, and these gametocytes are develop as a gametes. Here, means they are formed as a gametes. All the other stages, after the erythrocytic cycle, number of stages will be there. All the stages are entered through the biting and sucking of the blood. All the stages along with the gametocytes enter inside of the crop of the mosquito. Inside of the crop, all will be destroyed except the gametocytes. These gametocytes inside of the crop, they are formed as a gametes. Here, next. In the mosquito phase, mainly three phases are there. Here, in the raw cycle, they are having the 4 phases are there, not 3, 4 phases are there. In the life cycle of the Plasmodium life cycle in mosquito, or the RAS cycle is having the 4 phases are there. They are called as the first one is called as a gametogony. First one is called as a gamete. I will draw the diagram afterwards. First stages I am saying, phases I am saying. The first one is called as a gametogony. Second one is called as a fertilization. Third one is called as a formation of oocyst. Sorry, first ookinete and oocyst. And oocyst. Ookinete and the oocyst. Next, the last one is called as a sporogony. If you draw the diagram and these headings, easily you can get half of the marks. Means out of 8, you can get the 4 marks easily. Draw the diagram and main headings you are writing, then you can get the half of the marks. 4 marks you can get. That's why these headings are important. In the 4 phases are there in the Ross cycle or plasmodium life cycle in mosquito. First one is called as the gametogony. Second, fertilization, formation of ookinete and oocyst. Next is the sporogony. Next, I'll draw the diagram. The diagram I will explain. Means first, see this one. Gametogony is the formation of the gametes. Here, just a simple idea I'm giving. The gametogony means the formation of gametes. Either male or female gametes are formed. That we call as a gametogony. Both of them are joined and form it as a zygote. That we call as a fertilization. After the fertilization, they are formed it as a 2 stages. One is a vermiform stage, that is called as a ookinete. Another one is a round stage, that is called as a oocyst. After that, inside of the oocyst, number of sporozoites here in the sporozoites are produced, that we call as a sporocyst. Clear? Next, I'll draw the diagram, then you can understand easily. These 4 phases are important. See. One is this male, female gametocyte. Female gametocyte are also called as a macrogametocyte. Next, this one is the male gametocyte. Are also called as the microgametocyte. Next, this one is the flagellar body. Female gamete. Male gamete. This one is zygote. Vermicule. Are also called as a okinete. Next, this one is oocyst. Sporoblast. Sporocyst. Surely, here one more. I'll change this. One more stage is there, sorry. These are the sporoblasts. Then this one is ruptured and releasing the sporozoites. These are the salivary glands. Here the exflagellation. Exflagellation. Here this place we call as a gametogony. The three phases are there na? The three phases. This place is the gametogony. Next, this place is the fertilization. This is sporogony. Here the formation of oocyst and ookinete. That means, see, here the four phases are there in the mosquito phase. First one is called as a gametogony. The formation of the gametes is called as a gametogony. When the mosquito bites the man, the gametocytes are enter inside of the crop of the mosquito. Inside of the crop, they are developed as a gametocytes are developed as a gametes. They are the two types of gametocytes are there. One is called as a larger one that we call as a male gametocyte or also called as a female gametocyte. Second one is called as a the male gametocyte or also called as a microgametocyte. Here, the female and male gametocytes are enter inside. This is the crop. This is the mosquito crop. Inside of the crop, both the gametocytes are present. These gametocytes develop as a gamete. First, what in the gametocytes, gametogony, two stages are there. One is the formation of the male gamete. Clear? Formation of, see this one, I'm writing here. Gametogony. First is the gametogony. In this, which one is formed from the gametocytes? From the gametocytes, they are developed as a inside of the crop. The gametocytes are formed as a gametes. Here, that process is called as a gametogony. In this, two types of gametes are there. One is a smaller one, another one is a bigger one. Smaller one is called as a microgametocytes, are also called as a male gametocytes. And the larger one is called as a female gametocyte, are also called as a macrogametocytes. Here, macro gametocyte. Here, next, in the macrogametocyte, the nucleus is larger, and in the female gametocyte, larger in the size, but nucleus is smaller. What are the first? We are going to discuss about the formation of. Under this, one more subheading is there. That is called as a first one, formation of female male gamete. Formation of male gametes. How the male gamete is formed means this is the inside of the nucleus undergoes the mitotic divisions and form it as a 8 nuclei is formed. 8 nuclei is enter inside of the flagella-like structure. 6 to 8, the nuclei is present. These nuclei, each and every nuclei enter into the flagella-like structure of the cytoplasm and form it as a flagellar body. Here, form it as a flagellar. I will show in the diagram afterwards. First, listen. Flagellar body. The nuclei, forming nuclei, enter into the flagella-like structure. The flagella-like having the structure we call as a flagellar body. Like this, the flagellar body is there. Inside of the flagella, the nuclei is enter, and this flagellar body, the above the flagella, undergoes the lashing movement. Slow movement is occur. With the lashing movement, they detach it from the flagellar body. The flagella-like structure is having the lashing movement. In that time, they separate from the flagellar body. That we call as a exflagellation. That process we call as a exflagellation. First, the nucleus is undergoes mitotically divided and form it as a 6 to 8 daughter nuclei. These daughter nuclei enter into the flagella-like cytoplasmic process, and after that, this flagella-like structure having the lashing moment. With that lashing moment, they detach from the flagellar body. That detachment is called as a exflagellation. The flagella-like structure undergoes the lashing moment, then separate from the flagellar body. That process is called as a exflagellation. See, I will show in the diagram. See here. See, here this one is the male gametocyte that is called divided into number of daughter integers, say 6 to 8 daughter nuclei. These nuclei enter into the flagella-like structure, and this is called as a flagellar body. Above this one, the flagella-like structure undergoes the lashing movement and detach from the flagellar body. That we call as a exflagellation, and the male gamete will be formed. The flagella-like structure we call as a male gamete. That male gamete is formed, and now this is about the formation of male gamete. Up to here, the total yellow color. This one is the formation of male gamete. Now the next next one is the formation of female gamete. In the female gamete, the changes are occur, not more changes, just less changes are occur. What it is means, mainly it is having the fertilization cone. Here they are increase in size, enlarge in size, and the nucleus is comes to the periphery and form it as cytoplasm is having the one cone-like structure is formed, that we call as a fertilization cone. Means that with the forming of the fertilization cone is called as a maturation. Here they undergo in the female gametocytes. They are some changes are in that, some changes are occur and form it as the nucleus and goes to the periphery, and the cytoplasm is formed as a cone-like structure that we call as a fertilization cone. In this fertilization cone place only the male gamete will attach. Here male gamete is active, they are flagella-like, they are active and they are moving, and they attach to this place, that we call as a fertilization cone. Means the less changes are occur in the female gametocyte, just they are forming the fertilization cone and the nucleus is goes to the periphery. Clear? Next I'll show here. See, here this one is a female gametocyte. Just they are the nucleus here. It is formed, and the fertilization cone is formed. That we call as maturation. After the formation of the male and female gamete actively they comes and attach to the fertilization cone place, and both the pronuclei and the cytoplasm, both of them are fused and form it as the round structure that we call as a zygote. That we call as a fertilization. Clear? Gametogamy means up to the here only we call it as a gamete, formation of gamete. Next is the fertilization, means the male and female gametes are attached and form it as a zygote, that we call as a fertilization. Here the fertilization is called as a anisogamy. Here what it is? Here the fertilization we call as a anisogamy. Means the gametes are dissimilar in size and shape. That's why that type of the fertilization is called as a unequal gametes are there. That's why we call as that fertilization is called as a anisogamy. After the fertilization, the zygote is formed. This is about the fertilization. Next is the formation of oocyst and ookinete and oocyst. This zygote is there. This zygote form it as a worm-like structure. Means they are the elongated structure is formed that is looking like a worm. That's why we call as a vermicule or also called as a ookinete that is present inside of the lumen of the crop only. This inner side space we call as the lumen of crop. Up to here, the present in the lumen of crop. This the ookinete or the vermicule, they are first and means they are comes into the above the basement, beneath the basement membrane. They come and settle here. They pass the wall of the stomach and comes below the base. This one is a basement membrane. Below the basement membrane, they settle down and they are transformed it as a round structure that we call as a oocyst. That round structure is surrounded by the cyst. That's why we call as a oocyst. Here, this is the formation of ookinete and oocyst. Here, the vermicule first the stomach wall and settle down beneath the basement membrane and form it as a round structure that we call as that is surrounded by the cyst. That's why we call as a oocyst. Next, last phase that we call as a sporogony. Here the oocyst is having the nuclei. This is undergoes the according to the Bano, means the scientist Bano explained about the sporogony. According to the Bano, first the nucleus inside of the nucleus is only here it is only one nucleus. According to the Bano, the first the nucleus undergoes the reduction division. After that, the several mitotic division is occur and form it as a number of nuclei. Daughter nuclei is formed. These daughter nuclei along with the daughter nuclei, the cytoplasm is also divided, and each and every pronuclei or daughter nuclei takes the cytoplasmic bit and form it as a number of daughter individuals, number of sporozoites. That sporozoites containing cyst we call as a sporocyst. Here the oocyst undergoes the inside the nucleus undergoes the reduction division, and that is followed by the mitotic division, and the form it as a number of daughter nuclei, and after the forming of the nuclei, cytoplasm is also undergoes the divide, and the each and every nuclei takes the cytoplasmic bit and form it as a daughter individuals. They are called as a sporozoites. These, when the sporocyst is well developed, then they get ruptured and release the sporozoites. How many sporozoites are released means the 10,000 sporozoites are released at a time. Here in the sporocyst is having the 10,000 sporozoites are present. They are enter inside of the salivary glands of mosquito. After the crop, they enter into the salivary glands of mosquito, ready to enter inside of the another human being. Here, healthy human being. This total cycle is taken the time 10 to 24 days. Total, this raw cycle duration is 10 to 24 days. Here, this one is about the raw cycle. Here, one more time I will explain. See this one. I repeat one time, one more time. See this one. Here, mainly the 4 phases are there. The raw cycle is having the 4 phases are there. First one is called as a gametogony. Second is called as a fertilization. Formation of ookinete. And oocyst. Sporogony. These headings are main important. Gametogony. Under the gametogony, the 2 subheadings are there. They are called as a formation of male gametes. Formation of male gametes. Next is the formation of female gametes. How the female gamete is formed? Female gamete, mainly the inside of the gametocyte, the nucleus is undergoes divide and form it as a 6 to 8 daughter nuclei. These daughter nuclei enter into the flagella-like body. In the flagellar body, they enter and form it as a they are having this flagella having the lashing movement. With the lashing movement, they detach from the flagellar body and form it as a male gamete. Next, what about the female gamete means? Female in the inside of the female gametocyte, no, some changes only occur, and what it is means they are having the fertilization cone. The nucleus goes to the periphery. Clear? This one is about the gametogamy. Next, the fertilization means the male and female gametes fuse is called as a male and female gamete fusion is called as a fertilization. The result of the fertilization, zygote is formed. Here, this is here the male and female gametes are unequal, dissimilar, and in the shape and size. That's why we call as a anisogamy. Next is the third stage, that is called as a formation of pukinate. This zygote is form it as a next the worm-like structure. They are undergoes elongation and form it as a worm-like structure that is called as a vermicule, or also called as a pukinate. This is having the sharp needle-like structure with that deepers the stomach wall, and beneath the basement membrane they settle down and form it as a round structure. That round structure is surrounded by the cyst that we called as a oocyst. These oocysts are identified by the Ronald Ross. That's why he got the Nobel Prize, and that's why the cycle name is called as a Ronald Ross cycle. Here, next, this inside of the oocyst, the nucleus is there, and the nucleus is undergoes according to the Bano, the nucleus is undergoes the reduction division, that is followed by the mitotic division and form it as a several daughter nuclei form. After the formation of the nuclei, the cytoplasm is also divided and form it as a sporoblast. These sporoblasts are again divided and form it as a inside the number of sporozoites are formed. These sporozoites containing cyst we call as a sporocyst. After the developing, sporocyst will be burst and releasing of the 10,000 the sporozoites are released, that we call as a sporogony. These sporozoites are the reaches to the salivary glands. They're ready to enter the healthy person with the beating of the man. Here, this one is about the Ross cycle. This one is also important. Next, we are taking the one FAQ from this lesson only. The time is there, that's why I'm discussing the FAQ from this lesson. Parasitic adaptations. Mainly the parasites are present inside of the host. For the surviving, the hosts they are reject and resist the parasites. That's why the parasites are forming developing the different types of structures that we call as the adaptation. Special structures they are forming that we call as the adaptation. Means the parasites for the surviving purpose, they are present inside of the host. Hosts are reject or resist, tend to resist that one. That time they are forming the specialized structures, special structures. That special structures we call as a special structures. That structures we call as a adaptations. Here, some of the adaptations are mainly the parasites are developing. Parasites develop for develop attaching structures like hooks, suckers, rostrum. The parasites are developed for the attaching purpose. Some structures are forming that we call it as a hooks, suckers, and the rostrum. What it is means, for example, a tinea solium, the tapeworm. The tinea solium is present in the intestine. Along with the food, they eliminate outside. That's why for the attachment purpose means some parasites are present in the intestine or stomach. What will happen means along with the food particles, the undigested food, they are also eliminated. That's why they are having the special structures are present for attaching structures are present. These attaching structures are called as a hooks, suckers, and the rostrum. What it is means, for example, tinea solium is having the scolex is present. This is the scolex is having the teeth-like structures are present. These are called two rows of teeth-like structures are present. They are called as a hooks. And for the gum-like, the sticker-like structures are present. They are called as a sucker. And the conical structure is present that we call as a rostrum. Here, rostrum. For this, they are attached to the host intestinal wall, and also the suckers are present. With the suckers also, and the teeth-like structures are present. They are called as a hooks. Means the parasite develops the attaching structures like the hooks and suckers and rostrum. Example is tinea solium. Next, some parasites are having the outer side, they are covered by the protective cuticle or the tegument is present here. Covered by some parasites covered by cuticle or tegument, for protecting with digestive enzymes or neutralize the digestive enzymes. They are having the surrounding, they are having the cuticle or tegument for the side of that is helpful for the digestive enzymes. They are having the harmful enzymes are there. For that harm effect, they are protected. Here, next one is third one. Parasites laying number of eggs. Number of eggs. For example, Ascaris lays the 2 lakhs of eggs per day. Here, Ascaris more number of eggs. Here, Ascaris, they are laying per day 2 lakhs of eggs. And the tinea solium, tapeworm, tinea solium is having the 700 to 900 proglatids. They are having each and every proglatid is having the 35,000 of eggs are present. Here, the each and every means imagine the 700 into 35,000. That much the eggs are laying by the parasites. Here, next one is the Parasites secrete anti-enzymes. Secrete anti-enzymes for neutralize the digestive enzymes of the parasites. Here, the digestive enzymes of the host. Parasites secrete the anti-enzyme to neutralize host digestive enzymes. Host digestive enzymes. Example, here also, example is Taenia solium. Next, they are changing the every time parasite change the surface antibodies. Surface antibodies for escaping of the vaccines. For escaping with vaccines. Here, for example, here for this, the HIV and the plasmodium. HIV and the plasmodium. These are the some parasitic adaptations are there. Next, first they are developing the attaching structures that is called as a hooks, suckers, and the rostrum is present. Second, they are surrounded by the thick cuticle or tegument for the withstanding of the digestive enzymes of the host. And the third one is the parasites are laying the more number of eggs. For example, the Ascaris. This Ascaris lays the 2 lakhs of eggs per day. And the next one is the Taenia solium tapeworm, which is having the segment-like structures are present. They are called as the proglatids. They are called as proglatids. The how many proglatids are present means 700 to 900 proglatids are present. Each and every proglatid is having the 35,000 eggs are present. Like this, number of eggs are laid by the parasites. That is also one adaptation. Next is the parasite secretes the opposite to the reverse to the digestive enzymes. The enzymes are released that we call as anti-enzymes. What is the use of that means they are neutralize the host digestive enzymes. Example is Taenia. Next one is the parasites change the every time surface antibodies are changed. Why means the antibodies are changed means easily they can the vaccination. They are escaping for the vaccination. For the removing purpose, we are taking the vaccines now. That the vaccines are not helpful means the every time they are changed the antibody means they are not destroyed. That's why they develop the every time they change the antibodies in the surface. This one is about the parasites. See, the time is there. I'll explain one more time this one. See, I'm briefing this one. Again, the Ross cycle. See this one. This is the 2 gametocytes are present, female gametocytes and the male gametocytes. The female gametocytes are the less changes are occur and form it as a gamete, and the male gametocyte is also called as a microgametocyte. This is inside the nucleus is large and they are divided mitotically divided and form it as a 6 to 8 daughter nuclei is formed. These forming daughter nuclei enter into the flagella-like structures, cytoplasmic structures. They enter inside of that. then that is called as a flagellar body. This flagellar body, above the flagellar body, flagella-like structure undergoes the lashing movement. Here, that lashing movement is occur and they detach from the flagellar body. That process we call as the exflagellation. After the exflagellation, the gamete is released that we call as a male gamete. Here, and the next after that the gametogony next is called as a fertilization. This part is called as a fertilization. Male gamete is a flagella-like. Female gamete is a round and it's having the fertilization cone. They are unequal. That's why we call as a that is called as the anisogamy. And after the anisogamy, after that after the zygote is formed, that zygote the form it as a next it is form it as a vermicule, means the zygote is undergoes the elongation and form it as a the worm-like structure. This we call as a vermicule or also called as a vocinic. This vocinic comes the means they pass the inner wall of the stomach, they pass and settle down beneath the, this one is a basement membrane. Beneath the basement membrane, they settle down and form it as a round structure. That round structure we call as a the oocyst. Why we call as a oocyst means that is surrounded by the cyst wall. That's why we call as a oocyst. The center, the nucleus is in this according to the Bano, the nucleus is undergoes the first reduction division. After that, the mitotic divisions are occur and form it as a several daughter nuclei is formed. These after the daughter nuclei formation, the cytoplasm also divided into number of bit-like structures, and the nucleus is surrounded by the cytoplasmic bit that we call as a sporoblast. The sporoblasts are they are formed as a the inside of the nucleus. Again, they undergoes the division, and each and every nucleus takes the cytoplasmic bit and form it as a number of sporozoites that we call it as a the sporocyst. The containing sporozoites containing cyst we call as a sporocyst. And when they are well developed, that time they are burst and release the number of sporozoites. What about the sporozoites? Sporozoites are having the spindle shape. Here they are having the like this. The spindle shape structures are present. These sporozoites, how many are released means 10,000 sporozoites are released. These 10,000 sporozoites are enter inside of the salivary glands. Here from the crop, they enter inside of the salivary glands. They're ready to reach the healthy human. When mosquito bites the man, they reaches to the human being. Next, what is the duration of this cycle means? It is taking the 10 to 24 days. Inside of the mosquito, they are present in the 10 to 24 days. They are present here. This one is about the mosquito phase, are also called as a RAS cycle. One more time, we discuss about the incubation period and the prepatent period. Before that is the topic of the yesterday's one. Prepatent period. Is the time interval. Here, time interval between first entry of the plasmodium in the form of the sporozoite and the second entry that we call as a prepatent period are also time interval between the entry of plasmodium in the form of sporozoite and second entry in the form of cryptozoites is called as the prepatent period. Here, second entry is called prepatent period. Means it is the how much duration? This is having the 8 days. Next, what about the incubation? These are the important for the VSQs. That's why I'm saying incubation period. The time interval between entry of the plasmodium in the form of sporozoites, the form of sporozoites, and appearance of the malarial symptoms. Appearance of malarial symptoms is called incubation period. The duration, incubation period duration is 10 to 14 days. Means the simply because as a prepatent period means the completion of the pre-erythrocytic cycle duration is called as a prepatent period. Incubation period means the completion of the pre-erythrocytic cycle. The pre-erythrocytic cycle plus exoerythrocytic cycle plus erythrocytic cycle. Completion of these three cycles, the duration is called as a incubation period. Erythrocytic cycle. Here it is the 8 days. The exoerythrocytic cycle 2 days and the erythrocytic cycle 2 days, 12 days. Sometimes exoerythrocytic cycle is repeated. That time it becomes as a 14 days. Here, this one is about the prepatent period and the incubation period. These are important for the VSQs. Yeah. Next, this diagram is important. The stages are important for the LAQ. Next, tomorrow we will meet in the same time.